Hello, hello.
Hello. Good morning, everyone. Thank you, Mitali, for introduction. Uh, I'm going to give a brief talk on extrusion of aluminum alloys, die design and porthole dies, and evaluation of mechanical properties. And I myself, Vishwanath Ammu, I am a senior scientist in JNA DDC, and also I will be giving the brief details of activities which we are carrying out in our center. So JNRDDC, we are under Ministry of Mines, and we have got different divisions: bauxite, alumina, smelter, and aluminum, and electrolysis, analytical, and other services. We are extensively working on the process flow, like how the aluminum is being processed into different activities. Sorry. We have got different divisions like bauxite, alumina, smelter, aluminum, analytical, and other divisions. So we have got different kinds of expertise with us. And we are also ISO 17025 certified lab in mechanical and chemical categories. And also we are producing CRMs for aluminum alloys, different aluminum alloys, and it is under 17034. So coming to the extrusion process, there are different types of extrusion profiles across various sectors. So this is extensively used in building and construction, and again transportation, and most of the alloys are going for the defense and aerospace applications, and the future demand drivers are in the automobile and load bearing sections in building and construction industry. So coming to the alloys by chemical composition, it is 1 series and 3 series and 4 series and 5 series. These are non-heat treatable alloys. These are majorly 3 series are manganese based and 4 series are silicon based and 5 series are magnesium based alloys. And 2 series, 6 series, 7 series, these are the heat treatable alloys. And you can see the different kinds of application at the right hand side of the slide, the heat treatable category and non-heat treatable category. If you can closely observe, the non-heat treatable alloys are mostly used for the high conductivity type of applications, and where the applications doesn't require the properties not to be modified during after usage, that is the 3 series and 5 series alloys. That's why it is mostly used for the automobile and marine kind of applications. 6 series is most extensively used. There are various categories of 6 series alloys depending on the application. 6063 is one of the most widely used alloy, and 6061 and 6082, these are the high strength category type of alloys within the 6 series, and 2 series and 7 series are extensively used for aerospace and defense kind of applications. So you can see the properties of these alloys. When you go to the 2 and 7 series alloys, these are coming under the high strength category. They're extensively used for the where applications require high strength properties. But there are certain limitations for these alloys regarding the weldability and other properties. So the process is flowing like this. There is initially melt treatment and casting, and then homogenization, billet heat treatment, extrusion, and it is the profiles are subjected to the stretching, cutting, cooling, and also aging, and finish operations like anodization, painting, and fabrication. Each of these steps have got their own process parameters and the challenges associated with it, and I am going to briefly discuss about the how the extrusion quality of extrusions are defined by the die design and other parameters. So basically, the extrusion process is kind of a compression process, indirect compression process. We are applying the ram force, and this ram force is responsible for the shaping of the billet. So the main process parameters are the main process things are like the strain rate and the temperature. These are the main things, and how you are very well controlling these parameters will be defining the properties of the material. The first one is the billet quality. As we have seen yesterday's presentations also, the billet composition varies a lot with respect to the end use applications, and also within the billet how you are maintaining the chemical compositions within the limits and homogenization parameters, and also the flow stress parameters. So when you are trying to extrude at different properties, so the flow stress is more important. The flow stress, for example, the flow stress of 2 series alloys and the flow stress of 6 series alloys is entirely different. So because of that, this die design and everything will change. And also the process parameters, billet and container temperatures. So you have to maintain the billet and container and die temperatures so that there should not be much thermal gradient among the during the process. That will be responsible for the end material properties. And also the ram speed, this is also one of the important parameter. It is nothing but the strain rate, how fast you are extruding it. So this the 6 series alloys have got a different maximum limit of ram speed compared to the 2 series and 7 series alloy. So all shapes cannot be achieved at all speeds with the different alloys. So there is a process limitation for different alloys. So that has to be closely controlled during extrusion process. And also friction also plays a major role in determining the metal flow properties of these alloys. And die design, coming to the die design part of it. So in compared to other process like rolling and forging, so you can produce the different cross section of shapes by defining the different making the different dies and designs. So this is the beauty of the process. You can get the intricate designs very easily with the extrusion process. So how the geometry variables are varying the metal flow properties and the profile quality and other aspects which we are going to discuss in this lecture. And also the extrusion load is also very important. All profiles and all alloys cannot have different extrusion same extrusion loads, and they have got different extrusion loads. So this is how the material flow is happening during extrusion process. So you can see the movement of this extrusion. This is a direct extrusion process. So similar is the indirect extrusion process also, but slight variation will be there. So here there is a interface friction at the billet and container, and also there is a interface friction between the die and the workpiece. And also these frictions are responsible for the variation in the metal flow. You can see the metal flow patterns in different categories, like first is having low friction, A is having low friction, B is having the medium friction, and C is the worst case of friction. There are some dead metal zones formed inside the die during extrusion process. In this process you can see, so the right hand side below figure is representing the velocity distribution. You can see there is a huge variation in the velocity from the center to the edges. So this velocity variation is responsible for the die profile bending or twisting and whatever is happening during the extrusion process. So what people are doing is there are some compensations given to address these friction conditions, and those are called bearing links inside the solid dies. And also in this case die design is very critical to get the uniform metal flow. So these are the different types of shapes that can be extruded. For example, these shapes are what we have done in our laboratory. Everything, the dies and prototypes and all we have made. those profiles I have shown you here. There are two types of categories. One is the solid profiles, another one is the solid profiles. Those who are not having any enclosed volumes are the solid profiles, that is shown in the left side, and those who are having the enclosed volumes, those are called the hollow profiles. So the solid profiles and hollow profiles, there are these can be achieved by different dies. So the dies design is different for these two types of profiles. So I will show you the die designs for these two. The first is having the left side is the solid profile. So in the solid profiles, main thing is this friction compensation can be achieved by using the bearing length. Sometimes pocket is also being used. So this is the main thing. And the second one is the porthole die. In this, there are many geometric parameters which will control the profile quality as well as the metal flow. So this is solid profiles is this kind of section. I am showing the left hand side. There is a initial bearing design. Suppose if you are doing the initial bearing design with constant bearing length. So because it depends, bearing length is a function of distance from the center as well as the section thickness. So because of the velocity variation, there is a variation in the flow, and metal flow also will vary. So in this case, the bearing length optimization is important. In the initial case, it was initial bearing length was constant throughout. So that's why it has resulted in inhomogeneous velocity distribution. Second case, the bearing length has been varied with respect to the distance, and there is a calculation for this. So that's why the resultant velocity is the homogeneous velocity. So this is the porthole die category. Porthole die category, there are different types of geometries. Like initially the profile width will get divided. Initially the material gets divided, and then it joins in the weld chamber, and also it forms a seamless joint, a solid state seamless joint. And how this joining is determined by the weld pressure that is generated inside the weld chamber, and also material flow parameters, and also the temperature and other parameters which are being used. So these all determine the quality of porthole die, and this has to be extensively controlled. So there are various guidelines used for this kind of quality control of these porthole dies. First one is the bearing length height. Height of the bearing length is also important, and also profile width and welding chamber dimensions, how the flow is taking place. These are all various critical parameters which will determine the quality of porthole dies. So coming to the challenges which are very much experienced during the operation parameters, the process temperature is very much important. In case of 6 series alloys, the process temperature is not very much important. It is important, but still it doesn't have a very influential role on the process parameters. Suppose while transferring the billet from the furnace to the container, if there is a drop of temperature, extreme drop of temperature, 2 series alloys, it is extremely difficult, and we cannot extrude those things because of this narrow range of processing that is being limited by this process. So the extrusion ratios combined with the higher strain rates. Suppose 2 series alloys and 7 series alloys are having the very less extrudability. Because of that, higher extrusion ratios and higher strain rates are very difficult to achieve in these alloys. That's why I am showing the speed cracking defect of some of the alloys in the right side of this figure. Like there is a speed cracking defect, and also the extrusion could not be done and it has to be stalled in between during extrusion. And also the profile should be free from die lines and surface cracks and blisters. So these are various metallurgical phenomena also important for this during the extrusion process. Sorry. This is how the extrusion process is happening. The main influential parameters is the press speed and then the press exit temperature. there is an optimum values you have to determine. Otherwise, the quality problems will start to during extrusion process. In general, the higher alloying content and strength, the higher difficulty of extrusion and the lower extrusion rate. So that is what is happening in the 2 series and 7 series alloys. And 6 series and relatively easy to extrude, and 6 series 6063 is having 100% extrudability. We can see the extrudability of these different kinds of alloys, like 2024 is a 15%, 15 relative extrudability, and these ratings have been done with respect to 6063 alloy. 6063 is the most extrudable, and 6082 is having higher extrude, I mean 80%, 80 relative extrudability. So in JNRDDC, we are adapting this process modeling approach, like the material flow properties and all. We are doing various kinds of experiments for this flow stress data and all, and we are implementing these flow stress data values in the simulation software, and then we are making the solid models of the die, and also we are doing the press validations and also testing of the profiles. And on the right hand side, extreme right hand side, I am showing the special fixture we are using for the tube profiles quality control. And for the sections, other solid sections, we draw different samples at different location, and then determine the mechanical properties. And if the mechanical properties are not uniform, so we optimize the temperature and other parameters during the heat treatment and other processes. And we have got various characterization facilities, like SEM with EDS and EBSD, UTM, and metallurgical microscope. And also we use this for flow stress data. We use this hot compression samples as a special attachment for determining the flow stress values of the alloys at high temperature during extrusion. And also we have got the XRD, XRF, and ICP OES, and ICP MS, and optical emission microscope, which can detect up to 44 elements in the alloy. And we have got various simulation software, like Deform, HyperExtrude, and CATIA V5. And also it is combined with the different process equipment, like solutionizing, quenching, aging furnaces, and induction melting furnaces, and anodization. And current projects, we are working on conformal cooling of this aluminum alloy, high strength alloys. This is collaborators are from Bharat Forge and Entra India, Nagpur. And we are also developing medium strength aluminum magnesium silicon 608 based alloy with jointly with IIT Gandhinagar and also Siddhi engineers to develop a variation of 6082 alloy, which is having the highest strength compared to the traditional 6082 alloy. And also we are setting up a semi pilot plant for die sludge in alumina, geolite, and recycled leachate. Because when we do the caustic cleaning of the die, a lot of aluminum goes into it. How to recover this kind of aluminum as a value added products, that is also one of the projects. We are jointly working with ALEMAI, Aluminum Association Manufacturers of India, for taking up into the pilot scale. And also we have worked with yesterday one of my collaborator has given presentation. We are jointly working with seat frame, aluminum seat frames for passenger buses, jointly with ARAI. We are working on, and we have got various programs for skill development for different joint research projects, BTech and MTech projects, vocational training for students, and also educational visits and different workshops and seminars. And also we also offer various testing services, and we are also open for to jointly work with any laboratory or any institution in India. And currently we have added our DC casting facility with 300 kg furnace, and we can produce a DC casting billet of up to 2.5 meter only, and it is having 2.5 diameter and 6 and 7 7 inch, 6 inch and 7 inch um, billets we can produce it, and whatever alloy if we want to try, we can try with this facility, because it is not feasible always to try on the industrial scale. Initially we can try with the small billets, and we can use that extrusion facility to check the extrudability of this alloy, and we can integrate all the process. These are our various associates or customers. Uh, Thank you all for your nice attention. I also thank LMI for providing a platform to showcase these facilities. Thank you very much. If you are having any questions, I'll be happy to answer the questions.
Thank you very much, Mr. Ammu, for your lovely presentation and very insightful information. Is there any questions from the floor? Okay. Well, I guess the presentation was pretty clear then. So we're going to start very soon with the next speaker with us from Vedanta Aluminium Business, Mr. Ram Sandeepan Adhikari. And just give us a moment to change the dais over here. And before that, we would like to acknowledge the support and help of Mr. Ammu for coordinating a lot for our conference as well, and for this insightful presentation with a small token of gift. Thank you. Hello. Thank you for bearing with us. We have our next presentation and next speaker on the dais now. I would like to invite Mr. Ram Sandeepan Adhikari, Director Customer Technical Services, Vedanta Limited, Aluminium Business. Well, Mr. Adhikari serves as a director at Vedanta Aluminium with a close to 19 years of experience spanning process and quality control, asset management, control, customer services, and digital initiatives. A metallurgist by profession, Mr. Ram has held key leadership role in one of the world's largest aluminum smelters, that is Vedanta Limited, Jharsuguda. He's known for driving technical excellence in product innovation and customer-focused solution that enhances value and sustainability for the country at large. Thank you so much. I would like to invite Mr. Adhikari. Thank you.
Thank you very much, Mitali, for the kind introduction. And good morning, everyone. So today we are going to talk about how we are improving billet quality through practical routes. I'm not going to talk about something very, you can say, academic or what we can do, what can be done. I am only talking about what we are doing into our facilities, how we are making sure the billets are of good quality, how the things can be improved further, and how it is going to impact at the end of the day the downstream, the you can say about the extrusion process, how it is going to impact the anodizing, all those stuffs I'm going to talk. So quickly about the introduction, we are going to talk about Vedanta Aluminum shortly. Then we are going to talk about the approach, how we are taking these challenges of new development, how the things are, loops are getting closed. And then we are going to talk about the core concept, the basic engineering behind all the improvements, the science behind why this is happening and how we can improve. Also, we are going to talk about the capturing voice of customer, the actual operations that are happening, the digitization. Then we are going to talk about the new development that had happened and how it is impacting on the overall product quality. And last, we are going to talk about the what is the way forward, how we are taking forward the new, you can say, challenges, preparing for the upcoming future, where the things are going forward likewise. So if I talk about Vedanta, I don't think Vedanta requires any introduction. But when we talk about the different, you can say, product portfolio, the major important part that we are going to talk is basically with respect to billets, which is on the right side corner, where we are increasing our production capacity from 580 KT to more than 1.25 million tons. So that is our major, you can say, impact when we are talking about value-added product. And our basic, you can say, the approach is that how can we maximize our production capability with respect to value-added products. Currently, we are somewhere around 60%. We are trying to get it to 100%. How more we can do on the similar things. We also have value-added products like wire rods, where we're increasing capacity almost 50%. We are going with the rolled product division. Again, more than 50% production improvement is happening. So overall, we are looking for around 2.8 million ton of value-added products supplying to Indian market, out of which 1.25 will be only billets. So billet is our key focus area, and there we are trying to improve upon. Next, if we talk about our overall sustainability program, how we are not only preparing on our products, but also towards the environment. So if you see, we are already IITF certified. We have the BIS certification all there. One quick point to mention here is for the billet, there is as such no draft standard is available. The standard is in preparation form. Shortly, it will be announced. We are also part of the Aluminium Stewardship Initiative. We are S&P Global Certified second rank holder. We are the launcher of first India's green products, what we call as Ristora and Ristora Ultra, which has got a carbon footprint of less than 4 for Ristora and close to less than 1 is for Ristora Ultra. And right-hand side is mentioned are the commonly you can achieve goals that we are driving, the climate, community, people, waste management, energy, and the water part. If we talk about how the developments are happening basically, what are the approaches that we are taking? So again, it starts from the voice of customer, then moves to market analysis, the value generation, then converting the customer requirement into technical parameters, developing a product, and then going for our production, product launch. So all this, there is a different, you can say, entities who are involved, marketing, the customer technical support, production, and R&D, and each step has got its own responsible, accountable, consult, and inform teams. So everything is done in a very structured manner so that at the end of the day, everybody is informed and the correct decisions are taken on the right time. Now, if we were to talk about the basic of what is 6000 series alloy is, there are different alloy series for billet that we see 1000, 2000, 3000, meaning based on the alloying elements, different are made. But if we talk about 6000 series, which is close to 90% of what is currently produced or used in the metal, so we must understand what is the basics, you can say metallurgy behind this product, how these are basically impacting the production process. So if we look at, there are 6000 series, two major elements. One is silicon and one is magnesium. And the customer requires basically three things: strength, finish, and productivity. Now, if we look at this particular statement, the common thing that happens is something what we understand as homogenizing practices. If I have to talk about a very layman language, it is about inserting what we call as a in set of marbles, if you give a bigger marble, then the fluidity of the product will stop. The crystal deformation will stop, which is called solid solution strengthening. But to achieve that, you would require close to 4 to 5% of silicon to have that solid solution strengthening. But it will make the product very difficult to extrude. At the same time, there is something called precipitation hardening, where you take all the MgSi particle to a colloid and then you cool it and make it the grain boundary pins by this maxillicide, what we call. And at the bottom, you can see that is what is happening. So in this homogenizing process, the cooling rate and the homogenizing temperature are very important to do it. Now, another new thing that has come up, that if you have to increase the productivity, there is a way. If you reduce the magnesium, then it is MgSi that forms, and that gives you a better extrudability. But as soon as you reduce Mg, the strength also goes down. So to compensate on the strength part, you need to increase the silicon. And if you increase the silicon, the surface finish goes down. So in this case, we have to balance silicon and magnesium such a way the productivity goes up. At the same time, you don't sacrifice on the strength also. So silicon more than 0.5% actually hampers the surface finish particle. Now, along with silicon increasing, you can reduce the iron. So the phase that actually contribute is called AlFeSiMn. And this Fe particle, if you reduce, the beta particle also will be raised. And if this AlFeSi is less, then your extrudability will increase without compromising on the strength. Next step is that how to improve on the surface finish. For that, you need to add a bit of manganese, a very small amount of manganese that will help in accelerating the transformation and breakup of the so-called beta particles to alpha particles, and it will have a finely broken up alpha particle all over the matrix. So that is how it is going to help it. You can always add a bit of chromium. It's typical to the voice of customer. If the customer requires corrosion resistant, then the chromium is going to help them in having the corrosion resistant part. Also copper. Copper is basically help not only strength, but also helps in the bright surface finish. But last two are basically, you can say, it is subject to your requirement. If your customer requires all this, then only this is required. 6000 series as such doesn't call to add these elements in particular. Now, if you look at how do we convert the customer KPIs into our billet casting KPI. The customer requires three things, as we have discussed: the productivity, recovery, and the physical properties. And to meet that, in the billet casting, you need to design your chemistry and metallography accordingly. You need to have the metal hygiene so that there is no, you can say, inclusion in the product, and the dimension tolerance. So that at the end of the day, when the extruder is extruding, there is nothing touching on their container side, and the length is proper. There is no ambiguity on those types of things. So if you look at the basic KPIs, if you merge into all these things, the silicon magnesium graph, this is most commonly graph that you can see, is how 6060 looks, where is 6063, where is 6061, and where is 6082. So based on the strength requirement, you take different kind of alloys, and that actually drives your strength and surface finish. And of course, you require the CPCPK values, how best your CPCPK, the process capability is hitting. Like you need 1.33 to be at the correct value or more than that. But at the time of taking this project, it was CPCPK for silicon iron was 1.15, the magnesium 1.18. So how do we improve on that? So that was the ask basically. So do that. I have taken a very generic spec of, you can say, iron, silicon, and magnesium. and how do we improve the CPCPK values to going into a better dimension. Now, if you look at, let's take an example of iron. The typical values of iron, if you look at a normal distribution, it has to be in the middle range. But typically, if you target the middle value, which is 0.2025, 0.22, we end up normally at the end side of that. And that is because while you're using the different kinds of tools that is required for dedrossing, for mixing other alloying elements, always there is some kind of iron contamination which increases the iron value. So for this iron, you should not attempt the middle value, but to a lower value. Maybe if it is 0.22, you add at 0.21. So we'll land somewhere in between 22 and 23. So that kind of, you can say, practical intelligence we need to build on. Same for magnesium. If magnesium, if you are targeting 0.47 in the middle value, will always end up at the lower range because magnesium get oxidized in the process. So your CPCBA curve will look something like this. It will be on the lower end of the border. But the target is to go to in between 0.47, where most of the values are hitting. So how do you hit the middle point consistently? That's the ask. And to do that, we have changed this basic formula that you need to move on from the current set point to an improvised set point. If it is 0.17, move it to 0.16 for iron. For magnesium, it is 4.8, move it to 4.9, so that you know already there are losses are going to be taking place in the system, and you can make up for that so that you are there in that particular process. Also, it also depends on the sequence at which you are adding the particular raw material, and that's where it happened. I would just like to highlight one particular point, the third one, what is called garbage in, garbage out. If you put more, you can say, contaminated products into your furnace, there is no CFF or no degasser facility which will filter out everything. Ultimately, something is going to be end up into product which will compromise in the extrusion. So it is better possible if you are having a melting furnace, try to put less contaminated product and highlight those parts. So what we have done basically, we have developed an app. And all these calculations that are being done manually is put into app. So, and the app is connected to our laboratory system. What happens then? The operator only needs to see what is the value that they are getting, and the app will automatically suggest them how much silicon to be added, how much magnesium to be added. So first, there is no manual intervention. You can remove the complete calculation part. And second, the intelligence that we talked in the last slides, it's already built in the app. So the app automatically takes care of that, and you can call this a part of machine learning, which helps to improve that. And now you can see the results, how it has moved. The number of errors which were there earlier, which is close to 40, 45, it has gone to 0. And we are getting consistently CPCPK values of close to 1.8, which is almost hitting the middle point. So that is how the complete system, the problem we have identified, and we have done a basic, you can say, engineering into our system so that this improvement can be brought into. This is how the things are currently looking at, and where we are doing. You can see the what we call the app is FOMS, Furnace Operating Management System. And you can see consistently the values are close to 20, which earlier used to be much more. And this is, you also have the complete record of all products, which alloy has been prepared, how much silicon has been added, how much magnesium has been added. So all the complete backtracking and everything is available in this particular cases. So this is a digital way of going into what we are doing conventionally and moving into the new phase of things. Now it is a new offerings that we are going to talk about. Basically, there are 3 customer pain areas that we are looking into. One is that how we can increase the productivity of the billet, how we can reduce the breakthrough pressure to do that, and improve the recovery rates, and basically improve the dive lives. So these are the 4 KPIs that we are working on to make it happen. To do that, again, we are looking into the same chart, and this is what we are looking for, the alloy percentage, where our particular product we are aiming. The yellow mark is where our particular alloy is there. And second, on the homogenizing. So first is to optimize the chemistry. Second is to optimize the homogenizing. So if you look at the chart, it basically shows the degree of homogenizing, how fast we are cooling at, and at what temperature you are doing it. So if you are doing it too fast, then also the participation size is very small, which may impair product. If it is too slow, it will have a very coarser product, which will impact. So typically the range that is suitable for most of the 6060 kind of product is somewhere around 250 to 400 degrees centigrade, which gives you the optimum, you can say, the grain size to run your product faster and to have it on a better result. Second, when we are talking about homogenizing, one of the key parameters is the transformation, phase transformation from beta to alpha, and to make it more spheroidal. So there is some elements which is known as alpha stabilizer, which can be added to make the alpha particle more into spherical shape, which will give you a better result. So the plastic deformation process, it gives you superior surface finish. So now look at this trend. When we are done a sort of scanning electron microscopy of the grain size, you can see the blue ones, deep blue ones is where we have done basically the alpha stabilizer and the homogenizing optimization. And you can see the values are consistently lower than the green ones, where it was a non-stabilizer material. So what it happens basically, it reduces the grain size. And as soon as the mean grain size reduces, you get better outcome at the extrusion. This is the result when we have done the extrusion trial at various facilities. You can see the green ones are again where our high-speed billets are there. And the blue one, light blue one is basically where our conventional billet has run. So though the conventional billet was running at 150 to 160, you can say megapascal, and the speed was 2.4 to 2.5. As soon as we have introduced the high-speed billet, we can increase the speed up to 4 mm per second. And that actually translates down to close to 30% improvement in productivity. Of course, there are many other challenges that are there. That is, there is a puller available which can support if there is something. The die design is very critical where there is a critical groove is there. But for regular product, regular whatever your architecture or automotive, this product can give you at least 30% of your improvement. These are the few, you can say, derivatives that we have gone after. 20% improvement at least in the extrusion pressure. If not better, at par mechanical properties, you can get T6 properties with using that. There is no compromise on the strength. The die life improved, and the recovery rate, which is there with respect to pickup and other issues, that got reduced to by almost 15%. We are already launched this product, the high-speed billet. We are supplying more than 1,000 tons every month to various customers, not only in India, but also in Southeast Asia, Africa, Europe. So all these places, this product is very well accepted and used. I would just encourage you, if you have any kind of questions or any kind of queries, please do reach out to me. We can talk together and take this product forward. This is what we are doing as a next step. I think yesterday we had a presentation from our R&D team where we talked detail about the crash-resistant alloy, 7,000, 9,000 series alloys, modified 3103 alloy, how can we do more? Ultra-high strength billet, which can be used sort of doors and windows segment as well as into marine segment. So all these things we are currently working on. Though some of these have seen into the economic scale, we are doing some trial, and few are into the lab scale trial. We are working on the prototype, developing and taking this forward. The initial results are very encouraging, and with that, we are taking that. So if you have any questions around that, we will be more than happy to connect with your R&D teams to take this forward. Again, the major thing that we are driving is to have a vertically integrated supply chain, sustainability, and basically on the supply chain. So these are our key pillars to success. And we want not only to have a sort of, you can say, bookish knowledge in place, but to actually convert those knowledge into the economic scale where our actual extrusion is happening and how do we achieve those. So with that, we are working with our CTS team who are there to listen to your voices and taking this forward. That's what I had to say today. Any questions would be very happy to take and answer your questions. Thank you. Thank you very much.
Thank you very much, Mr. Adhikari, for your presentation. Do we have any questions from the floor for Mr. Adhikari? Well, thank you so much for your time and effort and for being with us and sharing the presentation. Just a small vote of thanks from our side, sir. I would now be calling our next speaker for the session, and he would present his paper on billet quality attributes for improvement in extrudability. Mr. Aryan Chauhan, Senior Principal Scientist and Head of Department Downstream and RPD in JNRDC. So, So Mr. Chauhan is a senior principal scientist at JNRDC, which is under the Ministry of Mines. With over 2 decades of experience in aluminum downstream processing, he has led 20 plus R&D projects in areas such as billet and strip casting, melt quality, and alloy development. His work spans structure, property correlation, product development, and circular economy initiatives across aluminum, copper, and zinc. I would really like to be really honored to invite Mr. Chauhan on the stage, please. Thank you.
Uh, Very good morning to all of you present here, and thank you for the kind introduction. Um, I'll just request the media team to make it the default resolution for the PowerPoint 16:9, the widescreen format. Otherwise, my equivox grains would appear strange to you, and you may not appreciate the particles, how they look, or how they appear actually under the microscope. So please do that in the meantime. So is the topic what I'm going to talk about is billet quality attributes for improvements in extrudability. I'm Aryan Chauhan. I have already been introduced. I represent Jawaharlal Nehru Aluminium Research Development and Design Center, an autonomous body under Ministry of Mines. And this is a Aluminium Research Center, and we have a dedicated unit for research on extrusion of aluminum alloys. This is the journey of JNRDC set up in 1989 by Ministry of Mines with UNDP support. In 2020, we have commissioned our own R&D extrusion press. This is 1400 ton extrusion press from SMS group. And subsequently, the post-COVID, there is a lot of transformation in the institute and the government policies. If you see, there is a more thrust, more push of sustainability, recycling after COVID, because after COVID, we realize how the resources are important for us, and how we have to secure our resources. So the focus is on recycling. That is what. And Ministry of Mines has created a recycling promotion division at JNARDDC. And also, we are the implementing institute for S&T Prism. This S&T Prism grants are given to industry and startup for launching, for initiating new schemes, or I won't say a scheme, it is for new technology introduction in the country. So grants up to 2 crore is provided by Ministry of Mines. Now we are also venturing into critical mineral. This is the vision, mission, objective. I won't read it out, but the last point, if you see, we have new objective added to our mandates is the recycling of non-ferrous metals, of course, including aluminum, copper, lead, and zinc. This is the layout as we do research on all aspects of aluminum, right from the bauxite, then smelter side, electrolysis side, alumina side. And this aluminum metal related work is focused in the downstream group. And as I said, Ministry of Mines has created a new recycling division. So these two divisions in JNE and ADC work on recycling and extrusion related activities for aluminum. This is the domain of expertise. If you see, we are 17025 accredited and 17034. We are the manufacturer of extrusion grade CRMs. Currently, we are selling 5 certified reference material which will help you for quality control, orders, compliances. We are producing 6063, 3103, 6082, 2024, and 7075 CRM grades that you can see the certificate of the elemental um, uh, tolerances in our CRM, which is kept at our stall number 31 in exhibition area. And this is our extrusion setup. If you see, this is 1400-ton direct extrusion type press, which is supplied by SMS. And we also have, excuse me, die design simulation facility. It's a kind of a complete solution, complete R&D facility for research on extrusion of aluminum. We can do die design, we can do simulations, we can do forward integration for your material, we can do backward integration for your required profiles. And we have billet casting facility. It's a 300 tank, which is around 150 liters capacity. And this is our reference material. We have recently launched 6082 also. So coming to the topic of my today's presentation, that is quality of aluminum billets that affects extrudability. So when we say quality of aluminum billets or the properties, what is our target? Are we targeting the mechanical properties? Are we targeting the aesthetics, or are we targeting ease of fabrication or ease of extrusion? If you want ease of extrusion, you want high extrudable alloys, obviously the mechanical properties for the same grade 6063 or the similar grades, it will be on the lower side mechanical properties. If you want to increase the mechanical properties, then you have less extrudability and aesthetics up. If you see, it will be a balance of all these. How do you maintain the alloying elements? How do you maintain the microstructure so that you get better anodization, better signing of your profiles? Uh, if you see any profile quality, if you try to divide between what is controlled by, so we have first is the billet as an input material. Billet quality is one. Second is extrusion quality, where the press variables, press alignment, ram speed, die design, extrusion variables, cat temperature have, what is the ram speed, what is the die temperature, and all these things. And for a recycling industry, if you see, you have kind of a casting checklist where before casting you check all the parameters where they're perfect for your casting or not. So you just go on ticking this. Okay, everything is okay. You go ahead with the casting. But here we are talking about billet quality. Considering all your rest of the parameters are perfect, your casting checklist is perfect. So what is the billet quality will depend upon the raw material input, how you are casting, and homogenization and the cooling cycle specifically. So various factors affecting extrudability of aluminum alloys. Extrudability, in general terms, we say quality of the billet. If the billet quality is good for different requirements, say from the mechanical properties requirement, say from the aesthetics point of view, say from the ease of extrusion. So all this point of view, you have different alloy composition. If you go on adding more alloying elements, obviously you will get more strength, but the extrudability will come down. Your more alloying elements, your liquidus temperature, your solidus temperature will come down. If your solidus temperature is come down, you will have the risk of melting during extrusion. That is why whenever you are going for more alloyed billet, your speed is reduced so that the elements or the particles or the grain boundary melting does not happen. Then magnesium and silicon content, obviously this is the, I mean, kind of most of the extruders or industry use 6 series production. So magnesium and silicon content, how many of you follow Hindi? आप लोग हिंदी कितने लोग फॉलो करते हैं? Good, good. Because we have a mandate that to talk to our stakeholders, being a recycling promotion division, to interact in Hindi. और हमारे स्टेक होल्डर्स भी चाहते हैं कि हम उनसे हिंदी में बात करें. सो माय प्रेजेंटेशन वुड बी काइंड ऑफ अ मिक्स्ड लैंग्वेज. अगर आपको प्रॉब्लम है तो बोलिएगा, आई स्विच बैक टू इंग्लिश अगेन टू एक्सप्लेन यू. एंड मैग्नीशियम सिलिकॉन में क्या होता है साहब कि जितना ज्यादा आप डालेंगे मसाला उतना ज्यादा आपका चोखा बनेगा बिलेट, है ना. लेकिन उतनी ज्यादा प्रॉब्लम आपको होती जाएगी. जैसे प्रीवियस स्पीकर राम संदीपन अधिकारी जी ने फ्रॉम वेदांता बोला, दे हैव इंट्रोड्यूस्ड हाई एक्सट्रूडेबिलिटी ग्रेड, they have introduced high strength grade billet in the same 6 series. That means they have reduced the alloying content. When they talk about the high extrudability, they have increased the alloying content of magnesium and silicon when they are going for high strength billets. और दी प्रोफाइल माइक्रोस्ट्रक्चर के बारे में हम आगे से अच्छे से बात करेंगे इन सब्सिक्वेंट स्लाइड्स. देन ऑफ कोर्स इम्प्यूरिटीज, इफ यू हैव सम alloying elements which can trouble you, or you have inclusions or hydrogen which can also trouble you, how to take care of that, or what are the problems that are associated with that. Then billet quality, external surfaces you always see कि उसमें लैप्स हैं, कि उसमें फोल्ड्स हैं, और हाउ स्मूथ इज योर बिलेट सरफेस. जितना स्मूथ होगा उतना चिकना आपका प्रोफाइल भी आएगा. चिकना इन द सेंस द क्वालिटी ऑफ योर प्रोफाइल. देन बिलेट स्किन, वी ऑलरेडी टॉक अबाउट बिलेट स्किन. कई बार इतना क्रिटिकल हो जाता है दैट यू हैव टू मशीन आउट द बिलेट स्किन सो दैट ऑल इम्प्योरिटीज, ऑल imperfections are removed before extrusion, so that you don't push the same impurities or imperfection in your profile. Then I am not talking about, this is not my area, my colleague Ammu may have talked about the die design and process parameters. Vishwanath Ammu, the earlier speaker in this session. So coming back to the billet quality from a metallurgist or metallurgical point of view, मेरा presentation साहब इस पे focus रहेगा कि as a metallurgist आप क्या देखेंगे बिलेट में कि आपका जो अल्टीमेटली जो प्रोफाइल है वो आपको अच्छा मिलना चाहिए. सो द कंपोजिशन ऑफ द एलॉय, डिजायरेबल एंड अनडिजायरेबल एलिमेंट्स. कुछ डिजायरेबल होते हैं, आपने तो कंपोजिशन मेंटेन कर लिया कि आयरन इतना होना चाहिए, मैग्नीशियम इतना होना चाहिए, सिलिकॉन इतना होना चाहिए एंड सो ऑन, बट कुछ चीजें होती हैं जो कि आपको नहीं चाहिए होती हैं, जो कहीं और से आ जाती हैं. स्पेसिफिकली इफ योर प्राइमरी प्रोड्यूसर, आपको कैल्शियम परेशान कर सकता है, आपको सोडियम परेशान कर सकता है. अगर आप रिसाइकलिंग इंडस्ट्री से हैं, आप स्क्रैप यूज करते हैं, तो कुछ वहां से भी इम्प्यूरिटीज आ सकती हैं. देन ग्रेन साइज, सेकेंडरी डेंड्राइटिक आर्म स्पेसिंग, सेग्रीगेशन एक बड़ी प्रॉब्लम है जो कि आपको माइक्रो स्ट्रक्चर में समझ में नहीं आएगा. आई मीन कुछ हद तक समझ में आएगा, लेकिन जो सेग्रीगेशन की प्रॉब्लम आपको तब समझ में आएगी, यू विल अंडरस्टैंड अबाउट द इश्यूज एसोसिएटेड विद सेग्रीगेशन व्हेन यू सी दैट योर एनोडाइज्ड प्रोफाइल इज शोइंग स्ट्रीक्स. कहीं पे डार्कर पैच आएगा, कहीं पे यूनिफॉर्म आएगा. This segregation reflects in your extruded profile, anodized profile. Then shrinkage and the gas porosity. अगर गैस है तो गैस तो तकलीफ देती है, हमको भी देती है, बिलेट को देती है, प्रोफाइल को देती है. And completeness of homogenization. So my focus is on this particular metallurgical features that you can think of that you should control to ultimately control the quality or extrudability of aluminum alloys. This is generic picture of any billet casting setup. पर यहाँ पे हम ये फोकस करना चाहते हैं कि जो आपका सम्प डेप्थ है, सम्प डेप्थ और जो यहाँ पे जो होता है मोल्ड के अंदर जो होता है, उस स्पेसिफिक फिनोमिना को मैं 1-1.5 मिनट के लिए डिस्कस करना चाहता हूं, ताकि आगे जब हम आगे जितना भी माइक्रो स्ट्रक्चर या बाकी चीजों की बात करें, वी शुड को रिलेट विद दिस पर्टिकुलर फिनोमिना. क्या होता है साहब कि when you pour your metal into the mold, it comes into the contact of the mold. ठीक है, जो एरिया आपको यहाँ पे दिख रहा है, मोल्ड का एरिया दिख रहा है, वहां से सॉलिडिफिकेशन स्टार्ट हो जाता है. सॉलिडिफिकेशन स्टार्ट होगा, द मोमेंट सॉलिडिफिकेशन स्टार्ट्स, aluminum can cause shrinkage of 6 to 7% when it is transforming from molten aluminum to solid aluminum. अगर इस 6 to 7% का shrinkage होता है, there is a possibility or there is a phenomena that the skin which is initially forming gets detached from the mold. That means the heat transfer from the initially solidified skin is hampered because of this contraction. Now you think there is a few micron skin just formed in the mold initially, which is holding the sump liquid, which is at 720 700 degree Celsius. जबकि जो स्किन बना हुआ है उसका मेल्टिंग टेम्परेचर होगा 660 645 के आसपास वो मेल्ट होगा. Of course depends on the alloy composition, but what happens, the sump metal is so hot, it is putting the metallostatic pressure, it remelts the skin, the whole metal expands again, comes into contact with the mold. This mold again takes out the heat from molten metal, again freezing happens and skin formation. This phenomena continues till the time your skin is out of mold and in direct contact with the water cooling. Once it comes into contact with the water cooling, there is no more melting or remelting of the skin. But क्या होता है जब बार बार स्किन की मेल्टिंग होती है, रीमेल्टिंग होती है, तो मान लीजिए कि एल्यूमिनियम एलॉय में जब भी एलॉइंग एलिमेंट्स होते हैं वो सॉलिड होता है तो एक्सेस एलॉइंग एलिमेंट लिक्विड में आ जाते हैं, फिर लिक्विड से सॉलिड बनता है, तो ये फिनोमिना चलते रहती. इसीलिए हम कहते हैं कि द स्किन ऑफ बिलेट इज imperfect. Skin of billet will have lot many impurities and defects. If you do not control your extrusion process properly, there are certainly chances that this skin imperfection will be pushed your profile, it will reduce your yield and so on. So continuing this talk, the generic specification for 6063 alloy, if you say the magnesium is 0.45 to 9, 0.2 to 6 is silicon, and what other parameters do you check or for your alloy? You're controlling magnesium, you're controlling silicon, you're of course checking the iron, but whether you are designing your billet or your alloy based on excess Fe based or excess magnesium based. Conventionally सबको पता है, everybody knows that excess Si is better than excess Mg based composition. That means the stoichiometric requirement of magnesium and silicon to form Mg to Si, which is the responsible for giving strength to 6063 or other 6 series alloys. Then this Mg2Si, again recalling the previous speaker's talk, he was talking about high strength 6063 and low high extrudability 6063. So this Mg2Si fraction, if it is more than 1%, you can say it is a kind of a high strength 6063 grade. If it is less than 0.7 Mg2Si concentration, then it is goes into the high extrudability, and the medium or the commonly people target Mg2Si fraction in their 6063 is 0.8. Mechanical properties, if you see, for qualify it to as a 6063 material, somewhere around 207, 208 onwards, you can go, and you can go up to 280, 290 in 6063 itself. While other electric parameters, if somebody is using for some other applications, the electrical conductivity, UTS and YS for the designers or fabricators, these parameters will be important. Now we have chemistry. Now we have mechanical strength, two of the requirements. Then how do you fix, how do you design, or how do you fix your composition? As I said, that excess silicon is preferred compared to excess MGSI, then Mg2Si requirement, because 1 to 2% reduction per silicon, excess silicon 0.1%, you will notice this reduction in extrusion speed. Then what I did, this is kind of billet, leaflet, or product catalog from some of the manufacturers. They try to qualify or publish their billet quality. Say they are saying other max is 0.01%, other 0.03 each. They are saying Fe plus Si is 0.45. After adding magnesium to alloy, a significant improvement is obtained in the internal structure of the billet. This is from ALUA. Huh? And typical range of Mg2Si is 0.76 to 0.82. Typical value of Mg2Si plus silicon excess is 0.8%. And this is what the industry in general follows. Yeah, let's try some calculations. First of all, I'll tell you the silicon has a preference to attach with iron, not with magnesium. The moment you add silicon, which also comes as a natural impurity in primary aluminum, this silicon will initially attach with Fe. And if you have manganese, it will go with that. The compound, the intermetallic that troubles all aluminum users is AlFeSi. And then balance silicon will be available for Mg2Si. That means if you're doing the calculation just based on your magnesium, okay, मैंने magnesium इतना डाल दिया furnace में तो मुझे इतना silicon इसको makeup करना and so on. That doesn't work. You have to take into consideration, भाई मेरे metal में तो already Fe, the Fe content is already so much. So I have to compensate the silicon which is going to be attached with Fe or Mn. Then the remaining Mg requirement can be easily worked out. Silicon required for Mg2Si is 0.58 times of magnesium content. If you just see these basic calculations, either of the thing you can take percentage silicon. So if you target 0.8 Mg2Si, as I said, for any general application, 0.8% fraction of Mg2Si divided by 2.3 plus Fe divided by 4, that will give you your silicon requirement. And once you get silicon requirement, you multiply by 1.3, you'll typically get the magnesium. So in general, you can have your own empirical kind of equations depending upon your feed material, because your feed material may be 6 series assorted scrap, maybe 6082 and so on, or some other elements like copper and other things may be getting introduced. So based on your own typical input material, you may work out empirical equations so that every time your composition is as per your expectations. But what? This is not one day's story. We did audit of one billet caster for 1 year, and the composition, every day's composition we picked up, 365 days composition. We checked how much is the variation in silicon, how much is the variation in magnesium, how much is the iron. And the frequency distribution, we notice that typically they are using 0.5%. The previous speaker was talking about the middle value of the Bell distribution. I put it in a different way, the frequency distribution, that what is the maximum frequency your billet is showing for any particular element. What is the excess silicon content? Because if you see these variations a lot, you being extruder or you being billet supplier, your extruder will say, भाई your billet is कल तो hard हो गया, soft हो गया, and excuse me, and so on. You too, you yourself will face these variations every day. Yesterday was this much breakthrough, this was the extrusion speed I could achieve, but this, if you control this, for that you will have to introduce this monitoring system. आप excel में तो data entry करते ही हैं excuse me, and do the see the frequency and find out. And over a period of time, 1 year, if you see, we noticed for that particular company, what is the average value, what is the majority of the billets they are producing, and so on. So this kind of analysis can be performed by you also, and specifically for the primary producers, if you have sodium in your metal, you have calcium in your metal, and for the if scrap being the feed material, there can be other challenges also. So these two elements should be checked because they will cause hot shortness or cracking of your profile. Coming to the cast grain size, we know that everybody says aqueous grains less than 150 micron is the desired one, or the S dash of 10 to 20 micron. The dendritic spacing should be like that. Okay, but where do you pick your sample from? Do you pick it from the surface side? Do you pick it from the center side? Or do you pick from the mid radius? We analyzed different sections of the billet, the top portion, the bottom portion, lengthwise I'm saying, and so on, different sections, and we picked, taken the sample from the surface side, taken the sample from the core, taken the sample from mid radius, and we found that the mid radius sample typically represents the average grain size. However, if your other parameters are fluctuating, you will have coarse grain also in the mid radius section. So to average out, you have to take the three samples from surface to the mid radius to the center of the billet, and coming to the surface segregation, recalling back that melting and resolidifying, melting resolidifying phenomena happening inside the mold, the this phenomena causes variations in your surface appearance. Say the first one is the smooth one, second we see the lap, and this protrusions kind of surface. All this is happening because of your melting and remelting. That is why if you see the air slip casting system, which controls the heat transformation because of the gap between the mold and the metal, gives you the best surface finish for the billet. And if you do the microstructure, you can see the surface imperfections for the air slip casting system. It can be around 250 micron, or even sometimes it is not present, or very less even. And for normal casting system or maxi cast system, it may go up to 2 mm, and so on. This is what is the tellable billets we have seen in the larger sizes. Then if you see what happens at the surface, if the segregation is there, there is called phenomena inverse segregation. That means there is a alloying element built up at the surface part. That means the surface is typically hard than its core or the other parts. And for number of billets, we have checked this surface segregation, and also across the radius, what is the compositional difference? Because what happens, your billet, some will have convective flow of the metal, convective flow because of the temperature differences, convective flow because of the density differences, and this convective flow will cause differences in composition or segregation of the metal in the radius part or the dia part, you can say. If this is not proper, this will reflect in your anodization as a streak defect. That means you're getting patches of dark appearance after anodization. Then what happens is the micro segregation. When we talk about the segregation within grain, means if your grains are larger, the allying elements will have to move larger distances, and this will affect your homogenization, this will affect your aging, these two things. So that is why we say you should have a smaller grain size, and if you homogenize, the further the segregation, the distribution of elements is homogenized. Then why do we homogenization? Of course, in industry it is less followed. In most of the places we have observed, भाई हमको क्यों करना है homogenization, छोड़ो ना, डाल दो billet, डाल दो, निकाल दो profile, निकाल दो. But what happens, आपको, you will experience this, if the billet is not homogenized, your mg, your alloying elements, they will be in coarser form, in as cast condition. If it is homogenized, it will redissolve into the matrix. During cooling, it will precipitate out as a very fine particles, very fine sizes. And when you do soaking or preheating before extrusion, it uniformly gets is dissolved into the matrix again. During extrusion, get mixed. During after extrusion, it again comes out as a beautiful, uniformly distributed, finer precipitate. That is how you get uniform properties. If you are not homogenizing, some of the particles which are present in your billet will limit your extrudability. They may cause hot shortness, they may start cracking, they may cause incipient melting also. And also during cooling, it is not just that you cool it, the cooling speed also matters. If you cool it at very high speed, do for example sake, you say you do the water quenching, of course distortion is one particular issue that you will face, but also the silicon gets entrapped in the system, which gives you higher breakthrough pressure. And if you do slower cooling, you will have coarsening of Mg2Si, which will again pose problem during soaking or preheating. While if you do controlled cooling, typically 400, after 400, around 400 plus minus 50 or so, you will have very good distribution of Mg2Si, which will dissolve compatibly. And the intermatrix, as I said, this LFESI, aluminum is born with defect unless and until it is ultra pure aluminum. Then we have to live with this LFESI, and with using scrap, we can see this with increasing content, we have increasing LFESI. However, there are two variants of LFESI. One is alpha type, one is beta type. Alpha is a spherical in shape, coherent with the matrix, while beta is the rod or the needle shape, which is less coherent with the matrix. This beta will trouble you during extrusion, it will accumulate various processes, various locations. But if you see these beta particles or these ALFESI particles after extrusion gets aligned. And if you see there are larger size, this will give your die lines and many other defects. That is why the homogenization is preferred. If you do casting at higher cooling rates, that also helps you in promoting the formation of alpha ALASI during casting. Then what about the homogenization practice? People say that, okay, we are giving billets of 90 This is from Alchem. And they say that my grain size is less than 130 micron, hydrogen content is less than 0.2 ppm, and homogenization temperature is 560, 575. Minimum alpha beta transformation is 90%. Then how do we calculate this transformation? Can we do it simply? Some of the homogenization temperature for various grades of alloys is mentioned it, but how do we claim that my billet has transformation of 90% alpha to beta? That is what is the question. Yes, if you see, this is the alpha, the beta particles. What we do that we identify each and every particles in the S-cast condition and the homogenized condition. Then we measure its aspect ratio, and thousands and thousands of particles we measure, and we take out the average and plot this kind of curve, that the circularity parameter of particles, whether it is shifting towards, and we take a pivoting point, say 0.5, and we say that okay, 90% of the particle has circularity more than 0.5. That is how my billet has kind of a 90% transformation of beta to alpha kind of, yeah. Then, yes, the circularity, if you compare for S-cast condition, you will get versus homogenized condition. You can easily measure the extent of transformation when you are doing homogenization. But mind it, in your homogenization furnace, we have done thermography, and if the temperature distribution is not uniform, say the top of the stack, top of the lay is receiving high more heat than compared to the bottom of the layer, then again the top one will be softer compared to the lower one. That is how the extruder or the operator will notice the difference. And what should be the typical size after this homogenization, the beta particle, the breaking of that? The necklace should be around 10 to 15 micron, the beads or the length of the beta, broken beta particle. Then mechanical properties, the variations can be observed, the conductivity, this is all composition and your aging parameter. If you do the combination of this properly, you can supply the required grade or specification to your customer. Then what about the surface roughness of the profile? We did, as I said, we did audit of one cast house, the billet caster, for 1 year. We tracked the billet, marked the billet right from the cast house to the extruder, the profile producer, and noticed that if the billet is homogenized, it will give better RA, better surface finish compared to the unhomogenized under identical conditions. Then we, we oh, yeah, yeah, yeah. So I got a reminder to conclude my talk now in 10 minutes. And yeah, so these inclusions, there is no point in talking about it. We know that there will be kind of oxides, there will be spinels, there will be borides, carbides, and so on. We are conversant with this. But sometimes, if your grain refiner, whether you are using Tibor or Tibol rods, or you are using the tablets based refiners, if it is not distributed uniformly, that too will lead to kind of inclusion. Means your grain refiner, if not properly distributed, will have appearance or properties or influence like inclusions. Then how do you check the porosity, which is going to be in the micron size? Can it be, it can be kind of interdendritic, the solidification shrinkages, or it can be gas related porosities. We do check with Zyglo dye penetrant and then UV developer kind of a thing, and check, and we found that the billet may contain interdendritic, which is the feeding related problem, or the gas type circular holes. So this is what is the summary of various metallurgical defects or parameters which we should consider while controlling the quality of the billet. So some of my suggestions are that maintain the chemistry variation, sodium, calcium, hydrogen content should be less than 0.2 ppm, higher casting speed will improve the billet casting or your cooling conditions, temperature zone in the homogenization, for instance, should be checked, and heat up during preheating of the billet during homogenization should not be very speedy. It should be slow ramping of the homogenization furnace so that your alloying elements do not melt. And according to 6063 specifications, if we want matte grade homogenization, take the iron to the higher side. Matte finish, like your some of the producer I may have mentioned that I deleted it. Yeah, Rio Tinto cans 650206063, they have increased the iron content intentionally because their customer is demanding the matte finish after anodization. Then you should practice higher homogenization temperature, of course, based on your chemistry, so that your ALFESI particles post extrusion are well broken and properly distributed to control the aesthetics or homogenization characteristics. Then what Mr. Adhikari, the previous speaker, talked, this is perhaps my last slide. You too can do branding of your alloys. You too can do branding of your billets. You can do branding of your profiles. Like the typical guys making the photo frame or the writing board, they don't require much of strength. They don't require much of the things. They need productivity, push 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 push. So you can control the chemistry so that they can get better extrudability. And the people who require higher strength than the normal one, you can grade your billets, your products by हम तो hard alloy hard 6063 बेचते हैं sort of. So you too can think of branding of your own product. And last is the melt loss. Of course, it troubles everyone, primary producer, secondary producer, whoever deals with molten aluminum, it troubles. And you should remember the 5 T's. One is the temperature you should control, time you should control, turbulence of the metal you should control, of course, the thickness of the dross or the type of the dross to be controlled. If you see the dross cracking inside the furnace, that means there is a phase transformation happening in the dross. It is going from gamma to alpha type, which includes the volume expansion. And if dross is cracking, the metal comes up on its own using the capillary, gets more oxidized. So be vigilant, be observe that your dross should not be cracking inside the furnace. Control your melt loss. You'll saving lot of metal, lot of money. Keep your doors properly closed. Do regular drossing. Don't wait for your operator. भाई जब वो आएगा तो charging कर देगा. Do promptly. Do not delay the furnace operations. Do observe your TOT time, turnaround time from heel to heel, whether it is 4 hours today and tomorrow it is 4.5 and 5 hours. Why there is a delay in TOT? And turbulence wherever possible. Keep the metal streamlined, flowing smoothly to prevent your oxidation or the melt losses. With this, I thank you for patient listening. And as I said, we have complete R&D solutions for extrusion of aluminum alloys. If you have any queries, please do write to us, and I'll be happy to answer any specific question in this forum. I don't think any. Yes, please.
Hello. So may I request you to please repeat your question on the mic so that for the benefit of the audience. Sorry.
Okay.
What?
I heard you.
Can you repeat your question?
My question is, hello. My question, cooling rate for a different alloy after that is 400.
Um, the typical cooling rate for the billet, the numbers I'm not recalling to be very honest, but the temperature range where you have to surpass that is the, again, I will take you to one particular, this is not responding. आपने बंद किया? When we talk about the cooling rates, see, the line that is marked as a solvus line, depending upon your Mg2Si concentration, whether you have designed your billet for 0.8 or 1 or 1 plus fraction, you should monitor the vertical crossing temperature, and that temperature has to be crossed slow, I mean at moderate speed, not very slow, not very fast. Otherwise there will be problem that the particles will come out of this below the solos line as a course, or if it is slow it will grow. So the particular temperature indication you can get from the fraction of Mg2Si on the x axis. Thank you so much.
Do we have more questions from the floor for Mr. Chauhan? Okay, I guess that was the only question for you, sir. Thank you very much for sparing time and giving us this lovely presentation. Very insightful, very informative. And I'm sure after we have ample time to actually, interact with Mr. Chauhan during the breaks, during the exhibition area as well. So thank you very much, sir. Small vote of thanks from our side.
Anyway, thank you.
Okay, now moving on to our next session. Actually, it's a panel discussion and the first panel discussion for Alumex Global Conference. We have a lovely lineup of panelists with us, very senior from the industry. Before I invite everyone on the panel, just allow us some time to set up the head table. And in the meantime, I'll give you a brief introduction of each of the panelists. So just give us a moment. Okay. So the support team will take some time to set up the head table. Meanwhile, let me introduce you to the panel. So the discussion is about Vision 2030 for aluminum extrusion, innovation, sustainability, and growth. What we would be focusing on: accelerating adoption for innovative technologies, supply chain, global supply chain, enabling innovation through collaboration, uh, industrial competitiveness, how to drive it, how to improve it, role of automation and future technology. I would like to introduce the first panelist, Dr. Rajesh G. Gunade. He is a renowned researcher in organic solid state chemistry and crystal engineering with over 20 years of academic and scientific experience, particularly in pharmaceutical application. He holds a PhD in chemistry from University of Pune and completed a prestigious JSPS postdoctoral fellowship at Kyoto University. Up next, our panelist is Mr. Krishna Kumar Anandan. He is the Chief Technology and Engineering Officer, Aluminium Downstream with Hindalco Industry Limited. Mr. Kumar leads technology and engineering function for aluminum downstream at Hindalco, with a career spanning over 2.5 decades in aluminum, specialty alumina, and 3 years stint at Novel in United States. Mr. Kumar is passionate about developing products and application and leveraging digitization in manufacturing that drive what we do at Hindalco, engineering for better future. Next is Miss Suzanne Dopp. She is the Vice President, Non-Ferrous and Additive Manufacturing Forging Plant with SMS Group, Germany, and brings over 15 years of leadership experience across steel, mining, and industrial solution. Previous senior role includes Head of SCM and Strategic Projects, Senior Strategy Professional, Head of Corporate Development and Project Management roles at various reputed organizations. Up next, we have Mr. Rajiv Maitra. He is a partner with Deloitte. Mr. Maitra is an experienced management consultant and digital transformation expert. And I am Calcutta alumni with over 22 years of experience, including 15 years in mining, metal, and industrial sector, leading 100 plus consulting engagements across top Indian and global companies. Our next panelist is Mr. Rohit Dev Burma, who is General Manager with Yantra Limited. Then we have Mr. Vineet Mahajan, the Deputy CMO at Vedanta Aluminium, a marketing specialist having more than 19 years of operational and leadership experience with expertise in B2B sales, distribution channel management, e-commerce implementation, handling responsibility of aluminum marketing through a cross-functional team of RMs, ASMs, with focus on efficiency, last mile presence, market innovation, and implementation of new technologies for better customer experience. And last but not the least, we have Ms. Debanjali Sengupta. She is the lead editor for Alcircle Private Limited. Debanjali, with over 10 years of experience in B2B and B2C content creation and editorial strategy, she has written across diverse sectors, including metal, finance, gaming, fashion, lifestyle, travel, and food. At Allcircle, she curates and develops content for the global aluminum industry, blending deep research with engaging storytelling. So with that, I would like to congratulate and invite all the panelists on the stage. Our stage is set. I would request all the panelists to kindly be on the dais so that we can start a panel discussion. Hello, hello, hello. Hello. Please welcome our panelists for a big round of applause. So over to you, Ms. Debanjali, the panel. Yeah, thank you.
Check in. Good afternoon, ladies and gentlemen. I'm honored to be present here and having this opportunity from ALEMAI to moderate this panel and sharing the stage with industry stalwarts. Hello, good lady, and all the gentlemen. I'm Debanjali Sengupta, your host for the 1 hour panel discussion themed Vision 2030 for Aluminium Extrusion, Innovation, Sustainability, and Growth. 2030 is certainly the year that we are looking forward to for many reasons. One key reason among them is definitely it is a critical milestone for meeting meeting emissions reduction targets. Many major aluminium producers and consumers worldwide have already pledged to reduce carbon emissions, like NALCO, who intends to produce green alumina and has designed its decarbonization efforts. Then Alcoa, who has pledged to reduce scope 1 and 2 emissions by 50%, and many more. But before we go into these key details, I would like to first know that how the Indian aluminum extrusion sector is growing overall. Because in a recent interview, Mr. Jitendra Chopra, president of ALEMAI, very clearly said that enhancing domestic consumption is the way forward for the Indian aluminum extrusion industry to grow. So this is a question which I would like all to answer to. That is the aluminium consumption growing substantially? And who are the key drivers for the growth? And if the consumption is growing, then do we have enough production in the market to meet the demand growth?
Good afternoon, everyone. The question related to how we are placed to counter the increase in demand. So prior to that, I just want to give you a brief idea how we are placed in comparison to the world. In India, the per capita consumption of aluminum is hardly 3.5 kg. Right? If we look at it at worldwide basis, it will be close to around 12 kg. Right? And if we talk about specifically about China, it is at 28 kgs. Right? So there's a huge demand because there are many sectors in which we are still not using aluminium, but we are using the traditional metals like steel. Right? So I can say that there is a huge demand in terms of where we can grow aluminium consumption in India, be it your building and construction, be it your automobiles, transportation segment, be it your architectural uses. So yes, we are lacking as of now as compared to the world. And believe me, in the next 15 years, we would see that this 3.8 kg will be close to around 10 to 11 kgs of per capita consumption in India. Now coming to the second part of the question, are we ready to to supply to this entire requirement that is going to come? So yes, we are also in an expansion mode. If we talk overall as a country, right? We at Vedanta, be it Hindalco, be it Nalco, we all have expansion plans. Specifically, since this is an extrusion event, so I would like to very categorically tell you about Vedanta. So at present, for extrusion segment, we do supply billets and we do supply ingots also. So at billets, we are at around 0.4 million tons of capacity as of now, which by next year will be increasing to 1.2 million. That will be 3 times, the existing capacity. And when we talk about the capacity, it's not only the numbers in terms of volumes, it also increases your requirements, like in terms of alloys, right? In terms of new sectors that you want to enter. See, traditionally, we have been consuming most of our extrusions in industrial or, building and construction or the regular state-of-the-art sectors. But with focus coming on in Make in India, we'll be supplying outside also, be it aerospace, be it defense. So the opportunity is huge, and we are very much in line to cater to that requirement.
Like to take up this case?
So I think the question is that how are we placed in terms of demand, right? So I just give you some numbers. So for that, everybody. So if you look at a global aluminum extrusion usage, globally is around 35 million tons, roughly 34.5, 35 million tons. And China is, of course, out of 35, 23.6 is from China only, right? Globally, if you see what are the end users that are growing out of this 34.5, the CAGR for the end use, which is very high compared to others, is transportation in terms of using, in rakes and others, right? So that's from a global perspective. Now, if I come to India, extrusion, if I look at the aluminum extrusion market, this year estimated to be almost 800 KT. Last year it was around 727 KT. And the fastest growing in amongst all the usages is consumer durables, which is like 10.6%. So and 10 to 11% is electrical machinery equipment and consumer durables. But transportation is, probably the lowest in terms of growth. So maybe that is an opportunity for us. And I think, as Mr. Murthy said, hello, some of the new age applications like aerospace and defense is going to also contribute to a large extent. And especially from a supply perspective, today our supply last is around 772 KT is the domestic supply, and we import also a lot. So 69 to 70 KT was imports last year. So clearly, I think there's also an opportunity for import substitution for certain products that we can look at.
Thank you very much. Anybody else who would like to take up this question, or shall we move forward to the next?
So I would like to bring ourselves to the purpose that we state, the purpose statement at Hindalco, which is that we manufacture materials that make the world greener, smarter, stronger. So as far as aluminum extrusions are concerned, we take pride that we are developing newer and newer applications. And that's one way in which we want to grow the usage of aluminum extrusions in India. For example, the last two major developments at Hindalco is development of battery enclosures for automotive, especially electric vehicles. And second is our foray that you would have heard recently into consumer electronics, and we are putting up about 500 crore investment. So for Hindalco, as we believe in engineering better futures, and our purpose is making materials that make the world greener, smarter, stronger. It's about developing new applications that are earlier not available, or so far it has been imported into India.
Right. I will come back to Mr. Mahajan with some specific questions for you, sir. How is Vedanta's aluminium business progressing towards its commitment to increasing the renewable energy share by 30%?
So yes, with Europe coming up with CBAM, right, and most of the Western countries, asking for low carbon aluminum now. So we have this net zero carbon emission by 2050 we want to do. We have already taken some steps in that direction. We already have our low carbon products with us now, which we are supplying to mostly to the Western countries. In India, the demand is not that much as of now, right? But we do have our two products. One is Restora and one is Restora Ultra. In Restora, we give 2.1 kg of 2.1 tons of CO2, whereas Restora Ultra is 0.5 tons of CO2. So having said that, we are using renewable energy to produce these metals. And we have a sister concern in terms of Serentica, who supplies us renewable energy, and we do buy from the grid also. But having said that, we are targeting that by 2030 itself, we'll be selling close to around 30% of our total production through renewable sources.
And how do you see these initiatives aligned with India's 2030 net zero vision?
So our Prime Minister is very clear, that that we have to be net zero. But then again, there are some balances that we have to see, because nothing comes free of cost, right? End of the day, renewable energy in today's scenario, it's higher cost, right? So we have to see whether the market is ready for this or not, right? Because are the customers willing to pay for it or not, right? That is also needs to be seen. Like I said, that in India, as of now, we do not see any demand for low carbon. There is a small demand, but that in the end, that they are the customers who are in fact exporting to the Western countries, right? But yes, Europe and America, we see a lot of demand, right? But again, there is a fine line, the fine balance between how fast we can grow in this. But if we feel that it will come at zero cost, it will not, right? So the cost balance has to be maintained.
Okay. Uh, One last question for you, and that is, as you are coming from marketing area, uh, do you believe that marketing can transform such technical goals into a compelling brand narrative? How do you influence the market with your branding and marketing strategies?
So yes, branding is very important. See, end of the day, aluminium is a commodity, right? And commodities, we generally in India do not see that sort of branding per se. Historically, we have not seen that. No, but now with focus coming more and more on global brands, right? We most of our consumers, entrepreneurs in India are collaborating with the foreign agencies. So yes, branding is there. But having said that, we also need to see that the global uncertainty in terms of, you can see US tariffs now, right? Or the geopolitical uncertainties, there are wars going on, right? So how much do we want to depend on exports, right? Because again, the most important thing for any industry is that the raw material supplies, the supply chains should be secure. Now in present day, when you say India branding, right? In India, we are fully aligned. We have our natural resources in terms of bauxite, coals, right? We can supply, we can produce within India itself the raw materials that is required for the aluminium industry. We are putting up, Vedanta is putting up so much new capacity to cater to the entire requirement. So the nationalism, nationalism in today's world is a very big word, because everybody is saying that make in USA, make and consume in EU. So we should also have the same target, make and consume within India, right? So rather than importing, because 60% of imports as of today in India, aluminium, it's imported, right? Gone are the days. It should be gone now. It should drastically reduce, because since we are talking about the extrusion industry, you must have all felt that scrap availability has reduced. That is because America wants to consume within America itself. So similar branding for India also needs to be done. And once, because in India we have this whole entire chain that is present. So it's just that time before we start utilizing it and making India branding again.
Right. Definitely, marketing plays a crucial role in giving life to mission and bringing it forth to the audience. But the real structure of the mission is also given by the technical team of any company. So, over to you, Mr. Anandan. Uh, what kind of basic infrastructure the aluminum extrusion sector needs to truly move forward on sustainability goals? And does India already have that infrastructure in place, or there are some gaps which we need to fill up?
Yeah, Debanjali, this is perhaps one of the most discussed subjects of late. So let me put it in a couple of ways. Number one, sustainability is at Hindalco, we believe in addressing it multiple ways. After all, we are the most sustainable aluminum company for 5 years in a row now. I would put sustainability in 3 Rs. One is recycling, the other one is resource conservation, and the third is restoration of the ecosystem. So recycling is perhaps the most impactful at this point of time in terms of sustainability, in terms of reducing carbon footprint. We are in the process of collaborating with others in the industry, and we have put up a 50 KT aluminum recycling plant in collaboration with others. And we would like to think that the way forward is to make sure that there is an ecosystem of collecting scrap, not just the end user scrap, post consumer scrap, but also the in process scrap, not just at our consumers, but also all the members of the value chain. That's number one. Number two is investing in technologies that help to better sort, help to better segregate. After all, you know, aluminum is not one metal. There is a component. There are multiple alloys and multiple systems, and our ability to sort and segregate in an efficient manner so that the right metal gets into the right furnace is very important. I think we are a long way from there in India, and a lot of efforts are being done, but we still have a way to go. The second part is about making alloys that are more recycle friendly, that can accommodate a wider composition and yet deliver the same functional properties. I think that's where Hindalco and its scientists are working on. On the other aspects, which is renewable sources, as you would know, Hindalco has an aim to have 30% of its energy needs met through renewable sources over the next 5 years, so by 2030. And about restoration, I mentioned about a word called restoration. It's about restoring back the water back into the nature. It's about restoring the land. It's about making sure that the biodiversity in the areas that we have our footprints or have had our footprints is restored back to its pristine condition. I think these are the parts of sustainability that we talk about. We have still a long way to go, but I am able to see that a lot of green shoots are on now.
So when we are talking about technology, Ms. Dope, I would like to bring you here in this context that do you think the role of technology is evolving at a very rapid space? Uh, because that's becoming a challenge to catch up with because earlier the primary role of technology was enabling smooth production, but it also now comes with the responsibility of driving sustainability. How do you see the significant shift in the role of technology?
Well, I wouldn't put it in the way that technology is evolving too fast, but a significant change that happened with sustainability goals and the very dynamic world we're living in today. Technology became more agile. We need to evaluate a lot of possibilities at the same time and change route quite quickly. There are some growth trajectories that we've been working on for years. And of course, there we're getting better and better and better. That's energy efficiency, that's electrification. But with the huge impact that we now see with driving sustainability beyond these things, we see technologies coming up like, for example, that are really innovative. We see people looking at heat storage in liquid salt to use it in billet heating. We ourselves in the industry already saw that permanent magnetic heaters are getting established technology. So a company like SMS, who features the whole line portfolio, and then for every step in a line, all the different furnace technologies, we have to evaluate a lot of things at the same time. We need to see whether we go hydrogen on burners or whether we go plasma or whatever we need to do. And at the same time, we need to cater different markets with different needs. So we are highly reliant on having good cooperations with our customers to get guided in the right way, because in the end, what you need, you know better than we do most of the time. And I think that is a challenge that we're having with technology nowadays, keeping pace with a lot of things.
Again, this question is for all, that how Indian aluminum companies, especially for the extrusion production, they're adopting this fast-paced advancement of technology. How often do you integrate new technology into your production process?
Hello. Myself, R.D. Verma. I am basically from defense sector, General Manager, Ordnance Factory, Ambajari. It's a Yantra India Limited, Erstwhile Ordnance Factory Board. Basically, we are being in defense sector for last 200 years, more than 2,000 years. We had been to this defense sector for aluminum product for last more than 50 years. So what we could see the changes in the current scenario, global political scenario and all these things. India is stood in one of the very important juncture to be self-reliance. To be self-reliance in this aluminum extrusion industries. Our focus should be in the very niche technologies. Commercially, like many speakers speaks about the commercial grade of aluminum alloys, like Hindalco, Vedanta, Nalco. Everybody's are very much competent and globally they're supplying the commercial grade of alloys. But defense and aerospace grade of material, very rarely in India, except one or two. Nobody is still enter into that area. But Yantra India Limited for last couple of years, we had been to Indian defense and aerospace grade of material. Earlier, prior to 2-3 years back, India almost 100% aluminum extruded product are being imported from outside. Mostly the high strength aluminum alloy like 2 series, 7 series and all. But for the last 3 years, we with our collaboration with HAL and all, now almost 80% we are covering to our indigenous requirement, and we are indigenization effort has been on. And in this area, Yantra India Limited is the only one-stop shop who has providing the aluminum, aerospace grade material like your T6 condition, control stress conditions. Nobody is manufacturing in India now. So with this emerging global scenario, India has to come up with a very big way. So in that direction, Yantra India Limited has already planned. We are acquiring 10,000 ton capacity extrusion press, probably the biggest in India, to cater the defense and aerospace application, particularly for aluminum extrusion product, for present and futuristic requirement. Because if you see the technology part of it, the commercial viability is very, very in stake, but the requirement, strategic requirement is very high. So if you compare the strategic requirement as well as the commercial viability, though it is not very much viable, but along with the defense and aerospace applications, if you go for the other area like transport, like EVs are now very much in the demand because of this carbon emission and all. Then also rail, high-speed train, and the renewable energy like in the solar and the wind energies. Everywhere you will find the application of aluminum extruded product. Almost 30-40% of the total structure is being utilized from the aluminum extruded product only. So these are the opportunities, and definitely like if you see the global scenario, I think the last year the total business all over the globe of aluminum extruded product is of around $940 million, and that is expected to grow by 4.5% CAGR, and it will reach by say around $1,400 million. by your 2033. So these are the opportunities. And in India also, that expected growth will be almost around more than 6% CGR. So in that area, definitely there is an ample scope. But along with the commercial part of it, we have to see the strategic part area also, like in defense and aerospace. So we, along with the Hindalco, we are collaborating each other, and as of today, we are almost meeting around 80% of the total India's aerospace requirement for the aluminum extruded product. And by 2030, by augmenting our capacity, like 10,000 ton extrusion press along with up and downstream facilities with all industry full compliant technology and all, we will be meeting 100% of our own requirement as well as for the civil aviation sector also. Thank you very much.
Ms. Dope, I will come back to you again with a question that how is SMS Group contributing to this evolution in technology?
So that is a very multifaceted question, and we are contributing in a lot of ways. What we had in the beginning of the discussion, we all touched on that we've got a growing demand and a capacity that is not yet up to the demand that is already created just standalone within India. Of course, one of our key traits is that we are there for the high-end products, that we deliver the technology that supports all the industries that also have partly the gap. If you're going into aerospace, if you're going into the complex alloys, if you're having, for example, the complex tube extrusion presses. So that is where we are supporting technologically, of course. Also for existing sites, bringing them up to speed, making revamps, improving your productivity with a big service team, and also added digital products that help you to keep better track of your production. That's, of course, our traditional business. And then secondly, we see ourselves also in the entire industry of plant equipment manufacturer is responsible for creating technologies that support the manufacturers, on the path to sustainability and on getting a good OPEX out of their plants. So these are certainly factors where we have a responsibility and where we are contributing. And the second thing we, of course, need to do, exactly like the manufacturers, the aluminum manufacturers need to do, we need to localize as well. And already 10 years ago, we set down the path that we move production here to India, that we manufacture in our own site. So we opened, I think in 2014 already, the first big workshop in Bhubaneswar, so we can produce the plants here, and will now follow beginning of next year with another workshop and more capacity here in India. So we support the sustainability, we support bringing in capacity, and we support the localization.
When it comes to technology, there is a lot to say, but the time is very little. So we will quickly come back to the importance of chemicals advancement, which also plays a huge role when we need to improve the production and the product quality. So, Mr. Moitro, how do you think the ongoing market dynamics and the advancement in chemicals is happening in the aluminum extrusion sector? Oh, sorry, I just called out the wrong name.
Yeah.
Sorry, Dr. Rajesh, sorry.
Yes, when it comes to the technology, the deep science is something which is related to technology. And unless you do the science, the technology completely depends on that. So when it comes to the chemical composition, I heard about this, the strategic sector contribution of the aluminum. It all depends on what the quality. The quality depends on the alloy types. So when you say I'm mixing the 5% of this metal, that metal, copper, magnesium, how are we mixing it? It's simply a mixing, and do you know where it is going in the structure of the aluminum? What is the FCC? What is the structure of the aluminum? What is changing? Because the structure relates to Hello? It's okay. So when you mix anything, any percentage, you have to know the deep science. You need to understand the material first, then only the properties, and then technology will come into the play. So unless you understand, unless you make your material quality, what what type of material you need, whatever property you need, you make it, then only your advancement. So there are different techniques by which you can, of course, know whether what part, whether there is a, when you are mixing it, it's a uniform mix. So uniform mixing, or it is a solid solution, or what kind of product it is. Unless you have the uniform mixing of this 5%, 10%, your product is not going to be a very good one, not very quality one. And then of course it will not give you any quality or whatever the property you would like, you are looking for it. So there has to be advancement in the chemical characterization of this metal alloys which you are making. There are different techniques by which you can do it, but of course you need a lot of high quality infrastructure for that. Then only you can make the material of the desired choice. So of course advancement is related to the chemistry. So you have to know, okay, when you simply say, okay, I have mixed this much, how it has been mixed, you need to understand that, and then only the advancement in the technology will come. So deep science is very important in this case. That is my purview of this.
Can you please brief us that the recent technologies that are happening uh, in the area of aluminum alloys, particularly for high performance and sustainable application?
I would not only comment on the aluminum alloys, any kind of alloys. Advancements are there. Definitely advancements are there. There are different techniques which you can use it when you make the alloys and all. But because I'm a material scientist, I can say that whatever technique you use, there is of course a different. It all depends on the what kind of material you would like to, whether for the strategic sectors or for the construction side or for any for the consumers, the household consumers and all. Okay, the chemistry, of course, is very important, and the processes are different for different kind of properties. But then you of course have to characterize the material with the different techniques which are available. Uh, that of course will give you whether the product is quality or not quality. Because when it comes to the global supply or something, your material has to be very quality, and it has to pass through all the characterization process, all the regulatory process and all. So that's what I'm saying. Okay. So not only mixing, not only making it, whether it has been properly mixed, whether the uniform mixing is there, not there, that has to be checked first, and there are different techniques for that. That's what I would like to say.
Okay. Mr. Anandan, even you can contribute to this. That in what areas technology and research, chemical research collaborate in innovation in the aluminum extrusion industry, or any point of time do you see they're colliding with each other, or there is a gap between technology, or
Can you repeat the first part of the question?
how or in what areas technology and chemical research collaborate?
Technology,
And chemical research.
chemical research. Okay, so
I can take this one. Interesting question, especially as Hindalco, in the last 3 years, we have invested in powder coating and anodizing sections. So there is a lot that we are learning in the process of developing a superior surface finish for our extrusion products. At the same time, coming back to the material content, the metal and the alloys, there is a lot of collaboration required, and the technology part here is where one of my R&D scientists is working on, is usage of artificial intelligence to develop alloys processes from the final material that we want to sort of present to the end consumer. So this is called an inverse problem solution, is wherein you look at an end product and then use AI to look at what all has happened over the past 20 years or so in either material development, in compositions, or in process changes that can help us to deliver that particular application. So there are multiple ways in which we can look at it. There is more and more need for collaboration. There is obviously no scope here for competition here, but I think there is a lot that industry and academia can do together in order to develop alloy properties or surface finishes that our applications in India require. That is how we will be sort of going towards the vision that my friend Vineet has mentioned, is move from 3.5 kgs to 11.5 kgs and then to 28 kgs of per capita consumption of aluminum in India.
Right. Technology and advancement in research for production is a pivotal role to play. But when it comes to trading, demand, and consumption, global trade policies and market dynamics equally contribute a huge role. So, to you, Mr. Moistro, how do you see the ongoing market dynamics with price volatility, high premiums, and steep duties to shape up the global consumption of aluminum extruded products?
Thank you. I think it's a good question. So I'm just talking from a point of view of India perspective. So as I said in the beginning, India is importing a lot, almost 70 kg of imports versus 30 kg of exports last year. And if you see India's exports, it has actually fallen from almost 40 plus KT to 30 KT. So average negative growth of 8 to 10% compared to import growth of 10%. Now, I think if I look at Indian exports portfolio, I think very important, I think there was a point around CBAM. So almost 70 to 75% of India's exports are primarily to the EU as well as to US. The remaining is primarily to countries like GCCs and maybe North African and MENA countries. Now, both CBAM has an important area, and I think it was mentioned by my speaker that how do we have lower carbon footprint in terms of people are looking at green aluminium, and green aluminium has a lot of premium in the market from a going forward perspective. So use of renewables is one area people are looking at, use of scrap, use of recycling, as well as with Mr. Anand mentioned about how do we actually have more of automation as well as so that I can have more efficiency in my process, efficiency in my production process, and thereby probably SMS also comes in from some of their new technologies. So I think there is a lot of potential from an exports point of view, from an India perspective, because today, India is kind of, the exports has kind of diminished. And of course, pricing is also dependent on in terms of how the overall market. We have seen the aluminum, the LME prices have more or less, I mean, it's not as volatile as probably, but I think the moot point is that exports need to be focused on, and how do we strategize for different countries, and especially CBAM in 2027. So that's going to be important. And also look at alternate export markets, and if I look at especially the African countries is one area, the Southeast Asian countries, South American countries. So we have to look at alternate export markets to boost exports. Clearly, there's a negative, I would say, trade balance from an India perspective.
I would like to hear from Mr. Murthy and Mr. Anandan that how have recent trade policies, whether the United States tariffs or free trade agreements between countries, have impacted your businesses?
So, see, at Vedanta, we do not have that much impact because very limited supplies of ours used to go to US. But having said that, the entire tariff change and the uncertainty around it has surely impacted the nature of business and the material flow that used to happen around the world. We'll see that in the last few months, probably a quarter or so, we have seen a lot of imports coming in into India. That is primarily that material which used to flow to the Western countries and it's not able to flow. But again, we see it as a temporary phenomena once the tariff issue is settled. So probably in a month or two, it should get back to normal.
So not much impact on our business.
Again, in lines with what I have been saying, this is actually a massive opportunity. On one hand, while we are worried about whether our exports will dip or not, on the other hand, as Mr. Burma said, there is so much that we can do in aerospace and defense and other new applications that I actually see this as a inflection point for the industry. Is whether we continue to do what we have been doing or we invest in, as we have been saying, in technologies and in developments to to meet the needs of our own needs in the aerospace, defense, and multiple other industries, consumer electronics for one, automotive for one. So this is a massive opportunity for all of us, and it was fascinating to see so many new players as compared to any other extrusion summit that we have seen. Is so many new players who are out there. You can see so many number of stalls that so many extrusion presses in India that are out there to meet this demand. So rather than looking it as something which is outside in, let us expand the pie that we need to play here in India and meet the requirements of our colleagues in the aerospace and defense industry.
So I think just to add to what he said, if I look at from a steel industry perspective, just steel and aluminum. So one of the major focus of steel industry is twofold. One is adoption of steel and usage of steel in newer areas. Secondly, the rural steel consumption. So similarly, we look at from aluminum perspective, how do we have adoption of aluminum? I mean, aerospace and defense is one example, but even in the transportation, because steel, I mean, steel usage has been going on. The second is how do I open up the rural consumption? Because I mean, it was mentioned that 3.5 kg is the per capita. I'm sure the per capita urban is much higher compared to rural. Right? For example, if I look at steel, 100 kg is the per capita, in terms of overall. Rural per capita is only 19. So clearly, I think rural market is also one. How do we enhance rural usage of aluminium can also be looked at. Newer areas, newer avenues.
Okay. Mr. Moitro, one last question for you. How do you see the growth in aluminum extrusion sector till 2030?
See, I think the projection is that this sector is going to grow, especially I mentioned that in FY25, the consumption or the market size is around 800 KT. The growth is a healthy growth rate. It is a 9 to 10% growth that we are estimating. And of course, with newer avenues opening up, this growth can be even faster. It can be plus double-digit growth. So I think what we need to do is, one is of course, for the newer areas, we need to kind of be closer to the market. I'm sure all the players are doing that, but especially for the downstream players who are there, how they are actually collaborating with the, end use, buyers is something that is going to be important, periodic. The second is how do we bring new technology into our, especially additive, especially new coating technologies and, using of AI and ML. I think these will be important. And so this growth is phenomenal. I think in India being the center as well as the bright spot in a global ecosystem, this is a double-digit growth we are expecting.
We come very close to end the session, but before we wrap up, I have two open questions for you all. Feel free to take them up. One is how well prepared is the Indian aluminum extrusion industry to face the upcoming CBAM regulations?
Hello. As far as your global scenario is concerned, I'm talking about aluminum extrusion industries. As up to last year, there is a almost 14,000 number of presses all over the world. Out of that, around 60% is covered by Asian Pacific nation. And then around 20% is the Europe, 18% something like North America. These are the overall scenario. So if you see the global scenario, maximum aluminum extrusion producer is of Asian Pacific countries, particularly China, then your Indonesia. Now, many countries are upcoming like this Vietnam and all, and India is one of them. So, out of that, more than 7,000 ton presses are located in Asian Pacific countries. But if you see the overall scenario, you'll find that we are concentrating less than 500,000 ton extrusion press and only catering for the commercial application part itself. We are not looking at the high strength aluminum side. So the trend is for going the increasing capacity of extrusion press because the many platforms like high speed rails, then aerospace, and then your EV vehicles platform and all. There is an increasing trend. And in the even chemistry also, apart from this your 2 series and 7 series alloy now is also emerging the aluminum lithium alloys, which is also emerging very fastly because it is more lighter. If you see the weight and volume ratio, that it is much more advantageous. So in that way, India has a biggest opportunity because we are having a bauxite, plenty of bauxites. We are having an infrastructure. So the market, if you see the market diversion, from Europe, America, and all. So slowly people are looking into the Indian market, and many aerospace industries are already established in India. So, and also India is looking for the high-speed trains, like you see the bullet or Vande Bharat and the bullet train and all, and even metros. So, in that sense, and renewable energies. So if you see in that direction, definitely there is ample opportunities, ample opportunities. And also if you consider about the technology, with the Industry 4 and AI compliant, we can reduce our cost of production by almost whatever yield we are getting now. Commercially, I think there will be around 80, 90%. And for the defense and aerospace application, it is around 70% yield. But with the using of new technologies like your Industry 4, AI application, we can increase up to 90% also in this niche alloys. So, as I said earlier also, the CGR growth rate of many consultant speaks about from 4.5% to up even 9%. So definitely for the Indian industries, I think these platforms will give you a lot of insights, and definitely we can have many more such kind of hello, where we can have many more sessions, and we can interact each other, we can take the help of each other so that we can grow faster. And India, you can see the government of India's Viksit Bharat 2047 will be one of the leader in these industries. Thank you.
Thank you. This was very insightful discussion, and it was lovely interacting with all. And so many aspects we have come across through this discussion, whether it's technical advancement, the marketing, the chemical research, the R&Ds, like all areas have a pivotal role to play in developing the aluminum extrusion industry, and we are all looking forward to its growth in demand, consumption, so we all are looking forward to 2030. And with that, on that note, we end the discussion here for today. Thank you. Thank you all. Thank you.
Thank you.
Hello. Thank you very much. That was really a lovely discussion and very insightful information from the distinguished panelists. Please give them a big round of applause for our distinguished panelists, please. I would now request Shri Charan Bajoria ji, our Vice President from ALEMAI, to kindly felicitate the distinguished panelists over here. Thank you so much. Please give them a big hand, please. Thank you very much, Mr. Mahajan. Thank you very much, Mr. Burma. Thank you, Mr. Anandan, Mrs. Ando, Dr. Gonade, Mr. Maitra, and Ms. Debanjali Sengupta for moderating so nicely this panel discussion. Thank you very much. Al Circle is also our lead media partner for Alumex Global Conference. I would request all the panelists to please come in front for a group photograph. Thank you very much, everybody, for your valuable inputs and insights. We will now break for lunch, and we'll be back here for our next session at 2:30. So kindly be back by 2:30 at the same conference hall. Thank you so much.